the main sequence of suns. The point is that the T-Tauri phase after the Protostar phase of a star has ended. And that had happened because the star has reached 10 or 15 million degrees Celsius. And that makes now thermonuclear reactions possible. Previously in the T-Tauri phase it was just a million degrees or a bit more, and then we also had 4,000. Enough to ionize the gases, so basically that we're losing an electron, and that the star was turning, so it was a big turning electromagnetic current. Now it's way hotter, 10 million degrees or 50 million degrees, and a thermonuclear reaction can happen. And inside of the star, by these 10 million degrees, it is so hot that the positive hydrogen atoms are moving so fast that they're overcoming the electrostatic repulsion. So they are repulsed, they don't want to come together, but now it's so hot that they're moving so fastly that they're sticking together. And they are forming a new element, helium. And that stellar nucleosynthesis causes now that there is an outward pressure. So the forming of two hydrogens together to a new helium causes now this stellar nucleosynthesis, which has an outward pressure, and the hydrostatic equilibrium happens. So basically there's so much outward pressure as there is pressure to the inside from the gravitation. So the sun is pulling together. It did it in the previous parts with the gravitational contraction. It just starts like that, just a bunch of dust pulling together stronger and stronger, and that loading it up with kinetic energy more and more, hotter and hotter. When it was so hot with the gas to ionize with the magnetic field, and now it had become even more hotter. The gravitational contraction has stopped because it's now so hot that there's an outward force through this fusing of hydrogen together to helium. And that can last, that's the longest phase of a star. By the sun, it lasts for 4.5 billion years already, and it's going to last again so long. It can be faster if it's a bigger star or sun, because then the pressure is faster, is higher, and the hydrogen is fusing faster together to keep the outward pressure standing. And it can be slower if the star is much smaller. I mean, it's going way smaller, but the hydrogen is formed. And also, by these reactor warps, it goes to the outside, cools down, goes in again, and also all the hydrogen in the outside of the sun is used up. So the main sequence, it is much pressure to the inside, very hot in the middle, and where the hydrogen is pressed together, forms new helium, which makes an outward force, and that is basically the hydrostatic equilibrium with this whole thing. That is according to Mark A. Garlick's Cosmic Many book on the page 38 and 40.